Hello everyone, welcome to this online course on manufacturing process. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So these are the overview or the topics that we are going to discuss in this lecture. We have already seen all the welding processes. Just overview we have seen means what is the meaning of fusion welding, what is the meaning of solid state welding, and briefly we have seen what is the meaning of gas welding, how heat is generated over there. So briefly we saw, and we have also seen the broad classification of the welding processes. Now in this lecture we are going to cover these four welding processes, that is shielded metal arc welding. What is the meaning of this one? Gas metal arc welding, flux core arc welding, and submerged arc welding. These four welding processes we are going to cover in this one. If we'll see this, all four processes are actually arc welding. Okay, na? All these four processes are arc welding. You can see here arc in all the four arc welding as well. Means what is the meaning of this one? The heat source which is required, or the heat that is required for welding, will be the arc. So it's very fundamental or very important to understand how arc is being generated, because in all these welding processes, arc is the main source of heat production. So one by one, we are going to see this one. So we'll start with the shielded metal arc welding. So shielded metal arc welding. This is the diagram we can see, but I will draw here a simplified diagram so that it will be very easy how actually arc is generated. So suppose this is the power source. This is the power source. Power source, and suppose this is the workpiece that we are going to weld, or where we are going to put the heat. This is a simple diagram. There will be electrode holder. Suppose this is the electrode holder, and simply the device we are using to hold the electrode, and suppose this is the electrode. This is the electrode. Okay, and this is the electrode, and then it will be in contact, and this arc will be generated. Okay, so this is the simple diagram. Suppose this is the workpiece. Okay, and this is your power source, and suppose current is flowing like this. Okay, this is at positive terminal and this is at negative terminal. Means electrode is at negative terminal and workpiece at positive terminal. So there is a technical name for this one. This is known as direct polarity, DP, direct polarity. And generally heat input at the workpiece will be more. So this is the simple diagram which has been shown here. Now other things are also there. Many things are being used. Like we have already seen in this area, if this is the arc area, so where actually we are melting the material that we are going to weld together, it need to be protected from the environment. If we are not protecting, then what will happen? Air will interact with this one. In air we know oxygen, that is very dangerous. Once it will react with this one, it will form the oxide. Whatever the material we are welding, it will form the oxide of this one, and oxides are generally very brittle material. So what will happen? Wherever the part we have welded, this welded structure will become brittle. So its strength, all these things will reduce over there. That is the reason we need to shield this area. So many ways are there through which we can shield, but two are broadly being used. And what are those two broadly used shielding operation? Is one, whatever the electrode we are using, that is generally coated electrode. Coated electrode means a flux coating will be there, and that flux coating not only for shielding, many other purposes are being there. Like if arc stabilization is there, other things also it fulfill the requirement. But if we have to cover the area, it will completely cover this zone. Will completely cover this zone. It's just like umbrella. We keep umbrella. Rain is falling on us. Although it is falling on us, but because of the umbrella, it cannot weight our body. Similarly here, what will happen? It will create an envelope. Okay, now the part we are welding or the weld pool where it will completely covered by this. Either it is flux over there or it is a inert gas. Inert gas means it will not allow air to react with that one. So it may be helium, it may be argon. Inactive, it may be CO2 or other. So what will happen? It will completely cover the area. So what will it will not allow to react, and then the part where we are welding, it will be completely free from the oxides and whatever the contaminations are. Okay. So this is the shielded metal arc welding. Shielded means this shielding is nothing but shielded metal arc means whatever the electrode we are using, suppose this electrode we are using, of course it is consumable as well as it is coated. Okay, na? So if it is coated, flux is there, it will be consumed means melted over there and being deposited, and whatever the flux are, it will completely cover the area. So this is shielded metal, of course, that we are welding, arc and welding. That's why shielded metal arc welding. In this process, a consumable electrode. So here the consumable electrode that we are using, this consumable electrode used as a filler material that will be filled over there, that will be deposited over there in the form of rod coated with chemicals that provide flux and shielding. Yeah. So it will shield as well as it will provide some other means property of the part we have welded together. The property in the welded, wherever we are welding, also it will enhance the property in many ways. Okay, suppose we have in that flux we have kept a particular combination. Suppose chromium we have kept and some other element we have kept for a particular purpose. So definitely it will enhance the property. It will enhance the its property in the form of hardness. It can increase its resistance towards whatever the other reactivity will be there. So many things it can enhance. Not only it will protect, depending upon what is the mixture of the flux that we are using as a coating material, that will lead to the enhancement of the many property of the welded structure. Okay, is used. Generally, filler metal has chemical composition very close to the base metal. Yeah, that is the requirement. It's not like always it is same, but most of the cases it is kept the same, very close to the base metal. Means if we are welding two mild steel pieces, suppose this is the one piece and this is the another piece. If we are welding together M1 and M2, so what will happen? Whatever the filler material we are using, this filler material, and whatever the coating we have done on, of course, filler metal will be of mild steel. The coating also the property will be related to these two materials. So it will be very close to the base metal. Filler rod coating generally consists of powder cellulose, okay, na, cotton and wood powders. That is the main element over there, mixed with oxides. It may be carbonates, it may be combined using silicate binder. Okay, so we are what we are doing, this cotton and wood powders are there, and it will be either mixed with the oxides or it will be mixed with the carbonates, or and when it is mixed together we need a binder. So generally this silicate binder is used to combine this. So it will be in semi liquid form. There will be a coating over there on the electrode. So this is the electrode, so outer it will have a coating like this. Okay, na? Coating will be there, small layer will be there, a very thin layer will be there on this electrode, that is actually coating. Okay, what is the current value? Many parameters are there. For example, this is the torch I am using for welding, so I have to move this. Okay, now speed also plays very important role. What is the speed of the torch? Means what is the welding speed over there? Similarly, other parameters are there. Means what is the voltage that we are using? What is the current we are using over there? Means all these are going to influence what will be the heat input over there, and that heat input that we are putting over there during the welding, in broad way it's going to affect the property of the material. So it's very very important to optimize these parameters. All parameters need to optimize. The very important parameters just written current and this voltage we need to optimize according to the material, according to the speed that we are using for the welding. So current is generally kept below 300 ampere and voltage is kept between 15 to 45. Okay, na? What are the applications where this process is being used? Many applications are there, but broadly it is used in shipbuilding, it is used in construction, it is used in machine structure. Means wherever the big constructions are there, this process are being used. What is the materials that we can weld through this process? So we can weld almost all grades of steel, whether it is a low carbon steel or medium carbon steel or high carbon steel, whether it is stainless steel or whatever it is, all grades of the steel we can weld by this process. Also we can, but the problem with this process is whatever the reactive metals are. Reactive metals means suppose aluminum is there, copper is there, titanium is there, magnesium is there. These are the reactive metals, very quickly react with the environment. Also, the problem is once their temperature will rise, especially aluminum. Suppose the temperature you are increasing during the welding, it will start to react with the environment. Okay, now so that is the problem, which is very difficult to weld by this process. So this is the drawback of this process. Although we can weld all the grades of steel, but it's very difficult to weld these reactive metals, especially aluminum, copper, titanium, etc. Okay, so this is the drawback. Another drawback of this process is as this electrode is consumable. Okay, now so suppose you are doing the welding, you are passing from this one point. Suppose you are moving from here to here for the welding. So what will happen? If it may be that during this portion the electrode is completely consumed. So what you will have to do? Again, you will have to take another electrode. So repeatedly you have to take the electrode. So that has been written. Repeated change of electrodes is required during the welding. That is the drawback. All the time, once completely the electrode will be deposited over there, you have to change and you have to bring another new one. Again, suppose you are going, again it will be consumed, again you have to bring. So this is another thing is current maintained in typical range. Yeah, that is the another problem. If this a particular range is there that you have to maintain the parameter. Beyond that you can't go, then there will be problem. So these are the two disadvantages of this process. Next, we have taken gas metal arc welding, that is GMAW. Okay, if we'll the first process we take here, it was a consumable electrode. Okay, so in this, whatever the process we are going to discuss, in all the processes, what will happen? Electrode will be consumed. Whatever the filler we are using, it will be of consumable nature. So second one is gas metal arc welding. This is GMAW. Here also electrode that will be used, it will be consumed over there. So here we are not going to use the coated electrode for the shielding. Instead, what we are going in this process, same process. This is also arc welding. As I said, this diagram is for this one also, how arc is generated. Okay, na? But what is the difference here? The difference will be for the shielding of this area, wherever we are doing the welding, coated electrode will not be used. That means flux will not be used. What will be used over there? The inert gases will be used to inert gases. Yes, inert gases will be used to cover this area. So those inert gases, it may be helium, it may be argon, or it may be the mixture of the gases. Inactive actually, CO2 is generally used to shield the area. Now the question will be which particular inert gas or the combination of or mixture of gases we are going to use to shield this area. That will totally depend upon what material we are going to weld. So in this process, electrode is a consumable. Means it will be deposited over there, it will be melted, and it will be mixed in the area where we are doing the welding, and continuously we have to change this. Okay, what is the diameter? Generally, its diameter lies between 0.8 to 6.5 mm. So anything between this, depending upon the material that we are going to weld, we have to choose the electrode. Shielding gas is provided separately over this one. So if this is the torch, welding torch, this will be there. So what will happen? You can see here the shielding, a separate port will be there through which shielding gases will pass, and it will finally reach to this area where we are doing the welding. So separately it is being provided. Okay, as I said, shielding gases, it may be helium, it may be argon, or the mixture of any inert gases. In active, generally CO2 is being used. How it will be decided which particular gas, inert gas we are going to use for the shielding? It will be totally decided on the basis of what material we are going to weld. Not only this one, what will be the volume flow rate over there? Everything is being decided depending upon what is the welding speed, what is the current over there, what is the voltage over there, and with what speed we are doing the welding. So depending upon these parameters, will decide what volume of inert gases will be there, as well as what particular inert gas we are going to shield the area. Okay. Compared to shielded metal arc welding and gas metal arc welding, compared to shielded metal arc welding, it can be used for multiple weld as there is no deposition of slag, hence brushing is required. Yeah, this is very very important to understand. In shielded metal welding, what was the problem? As flux we are using, so what will happen? Once we will do the welding, slag will be there on the welded part, so continuously brushing is required. or generally whatever the electrode we are using, the wire in the form of electrode we are using, it will stick to the part where we are doing the welding. So continuously we need to do the brushing, but here this is not the case. The electrode will not stick with the workpiece, so we don't need brushing. So what we can do, continuous welding, a long run continuous welding can be performed by this process, which was the problem with the shielded metal arc welding. That point has been written, and this is of course the advantage of this process. Another thing is, it can be automation of the welding possible for the continuous weld. Yeah, it can be automated. Many trolleys are there where you can place the torch and automatically it can do the welding. So you do manually, you don't need to do that. This one. Another thing is also called. This is also called as MIG welding, means metal inert gas welding, and CO2 welding also, when CO2 is used as the inert gas in this process. Okay. So next process that we are going to discuss is, the next process is flux core arc welding. So flux core arc welding actually is also known as a dual shielding welding process. This is also arc welding. So same diagram here also is going to be valid, means you will have this and then you will have workpiece. Suppose you have to hold the electrode holder will be there, and then your electrode will be there, and the arc will be generated, but there will be difference. What will be the difference? Here the it will be double shielding is there, means double shielding means, that's why reason it is known as dual shielding process. Dual shielding means electrode, coated electrode will be there, as well as shielding gas will be there. So how it works actually? So it is a semi-automatic process, and uses continuous flux field, continuous flux field wire electrode, continuous in tubular form. You can see here, this will be in tubular form. So it carries both electrode with the flux, means coated it is, and shielding for the gases. That's why it is self shielded flux core arc welding and gas shielded flux core arc welding. So what happens here, in arc welding process, the electrode is a continuous consumable tubing that contains flux. So both can be used simultaneously. It's a very versatile welding process, and it can be used for heavy construction welding. It can be used for manufacturing, and the best advantage or the best thing about this welding process is, it can be used for all the position welding. All the position means, if overhead we are doing horizontal welding, we are doing vertical welding. For all the positions, this process can be used. That is the most important advantage of this process. Remaining almost all the things are same as we have discussed to two arc welding processes. What is the different here? It is the dual shielding process, means both shieldings are there through the flux as well as through the shielding gases. Another thing is, it can be used for all the position welding. That is the reason it's considered a very important welding process. Next welding process for today, this is the last, is submerged arc welding. Submerged arc welding means, the name submerged itself is, this is for flux. So what will happen, wherever we have to do the welding, flux will be completely covered that area, and then we have to do the welding. So you can see here, through hooper, this granule of flux. So this will come continuously, it will come. Okay, now, and then we have to do the welding. Remaining things are same. Remaining things are same means, here also you have to produce the arc. Arc will be generated. Shielding gases will be there, or you are using this. Sorry, not shielding gases will be there. This flux where you are putting in the part that we are welding, it will cover the entire area where you are doing the welding. So it will not allow the environmental gases or environmental oxygen to react with the part that we are welding over there. So it will work as a welding. Not only it will work as a welding, what it will do, it will also stabilizes the arcs over there. So whatever the arc we are creating, through that we are generating the heat over there, it will also stabilize the arc. Another important property of this process is, what it does, just see this line. Okay, one moment, see, this is a continuous bare electrode wire is used here. Continuous bare electrode, why bare electrode is used? Because we are separately putting the granules, small granules of flux. for the shielding. So there is no requirement of shielding gases, or there is no requirement of coated electrode. So bare electrode is used. Shielding is provided by external through the hooper. This granule of flux through the hooper. We have already seen this one. Flux just before the arc weld. Yeah, we have seen. Flux completely provides the protection from the sparks, spatter, and radiation. Yeah, it is just like a blind welding. Blind welding means we have all this. Flux will be like this. Suppose it is completely shielding the area where we are doing the welding. So if we are doing the welding, suppose my torch is going inside. So what will happen? The whatever the arcs are there, it is completely covered by this flux. So what will happen? There will be no spatter come out, there will be no radiation. So what will happen? Although the welder or the person who is doing the welding, he don't need to cover his eyes, he don't need to wear the safety equipments, because already this arc is completely covered. That has been written here. There will be no sparks over there, there will be no spatter over there will be no radiation over there, and hence safety glasses or gloves can be avoided. That is the advantage of this process, because our whole the area is covered through the granules of the flux. So there will be no chances of sparks, and there will be no chances of spatter and the radiation. So whoever the welders are, for the safety purposes, if you don't wear glasses or you don't wear gloves, it is perfectly okay. There will be no problem. What happens? The most important thing is some part. This is very very important. Some part of the flux get melted and forms a glassy layer. Yeah, whatever the flux that is there over there and arc is there. So what will happen? Some of the flux will be melted and it will create a small layer, which is the name has been given, that is glassy layer. It is very very important. This glassy layer and unfused flux result in slow cooling rate. So what happens when we are doing the welding? What will happen after welding? You know there will be temperature difference. So slowly it will cool over there, and cooling rate plays very important role to decide what will be the property of the welded part. So if cooling rate is slow, it will improve the mechanical property of the part we are welding. So this is the very very important point to consider in this process. Because of that, a glassy layer and unfused flux, it will reduce the cooling rate over there wherever we are doing the welding, and because of that its weld quality, of course its mechanical property and weld quality will improve. What is the application? It is also used for longitudinal and circumferential welds for the large diameter pipes, tanks, and pressure vessels. So this is all in this lecture. We'll stop here. We'll again meet for the next lecture. Thank you.